Okay, here's video 2, where we're going to do the slider crank as opposed to the crank slider. Here are our equations to build up this tool, and we'll proceed. I'll put them on here, the equations onto here to make it a little easier. Here are the values. We'll use these from the example 4.3 out of the book. And I proceed to make the K1. So we take a squared minus b squared plus c squared plus d squared. Boom. And then equals, let's see, we have minus 2 times a times c. And then for K3, we'll have minus 2 times a times d. For our a, we will have K1 minus K3. And for our capital B, we'll have 2 times K2. And then lastly, for capital C, we will add K1 and K3. In order to get the angles, theta 2, we take 2 times the arctangent of the quantity, negative capital B. This time we'll go plus the square root of capital B squared minus 4 times capital A times capital C. Close the parentheses for the square root, close the parentheses for the numerator, divide by parentheses for the denominator 2 times A, close parentheses for the denominator, close parentheses for, that should be for the tangent. Let's see what we did. Boom. Let's see how it turns out into degrees. Those were radians, and we end up with a large number. Oh, name. Oh, left out the F in degrees. Do that a lot. Okay, so there's one answer. And let's check. Here's theta 2. We'll copy that and bring it back down here. The only thing that needs to change is now that's a minus. And we could do the same thing for degrees. We could put these degrees everywhere. Now, I have a couple of, for theta 3, I have a couple different, that doesn't belong right there. That was a mistake. I put the radians, or turned the degrees and all the other spots right here. For theta 3, there's a little bit of an issue that there's a couple different equations and you'll get the wrong answer. In several of them. So we really should check what the distance that we get right here is. So you might have to draw this out or sketch it out. It's because the thing can flop around, and also that there's signs can give you a positive or a negative answer. Well, they can give you an incorrect. There could be ambiguity when you're taking a sign. In which it could leave out one of the answers. It could either be the one quadrant or another quadrant. That's my explanation for it. And I guess I didn't include this other thing. Okay, anyway. So let me put this in here, and we'll write down that we'll start out with the arc cosine of A divided by B. Right, so that's down here, times the cosine of my first answer, close that parentheses, and then minus d divided by a. And I think I closed the whole thing. Oh, and I got something wrong here. Let's see, what did I do? Times there. I went, following this guy right here, I went arc cosine A over B. Arc cosine A over B times cosine of that minus my D over B. I think I accidentally hit that instead of that. Boom. Okay. Now I want to check what D is equal to, and that doesn't show up anywhere right here. I have to open up some of my notes over here to get that, what that is down here. So hopefully this won't bog down my machine too much. It's feeling kind of slow today. Yeah, the PDFs are really slowing this thing down. I think this is going to be the one, yeah. And I'm going to grab a hold of these equations right up here on the top in order to calculate what D is. Okay, so it copied it. I'll close out of that because it's really bogging down my machine. And so right here, these were the main equations that we started out with, right? This is the x of the vector loop, and that's the y of the vector loop. So if we want to calculate the D, all we need to do is calculate that side right there. So it goes equals A times the answer we got up here. Oh, no, excuse me. A times cosine of the answer we got up here minus B times the answer we got right. Nope, sine. Is that true? No, cosine. I'm trying to do this equation. Come on. Cosine of the answer we just got. Boom, we got 100. We know this one to be true. This next angle is very tricky. It's kind of annoying me, to tell you the truth. We could try out what we just did right here for this one. And all we're going to do is change what this angle is, and then we do this check in a similar way. And we bring that down and that down, right? Boom. Oh, it says that's correct. Huh, interesting. I wonder if I made a mistake on a previous one and I've caused myself all that hassle. I think this is correct right here. So both of those angles are correct. So let me just mention that I have run into a scenario in other problems where we have to use this guy over here, right? You can see me waving my thing around. This is the sine. Of course, that's really based on using this equation going backwards and getting that theta 3. And now we actually have the c in there. The book has a totally different equation, or not a totally different equation. It has a different approach where it makes this part negative over here, and then it adds, well, 180 degrees or pi to the thing. If you run into that, you're going to have to work through and figure out what this other angle is. The saving grace that we can have is that we could plot the thing out and see what it looks like. Let me get rid of these things over here. And so the 0 right there, or the O2 I should say, is going to be 0 everywhere. A, for this one, it's going to actually be different than in some of our other examples, because this A is, the point A is determined by the angle, the theta 2, which is what we're solving for, right? So we want to take the cosine of that angle, and that should give us the right answer. That should give us that first point. Then we take A times the sine of that first solution, theta 2. And then for, I'm going to go backwards for point B, right, or O4, which is what the point I'm calling this point right here, even though it's not labeled that. It's not a fixed point like most of the O4s are in the other arrangements. The X direction is going to be D, right? And then it's also going to be on the this x-axis, so it's 0. And the same thing true right here. And right, and I'm entering in numbers because it's always going to be that. While I'm here, I can also do the other configuration where I'm going to go A times the cosine of the other answer right here, boom, and then equal to sine of this guy, yeah, that other answer right there. Nope. A times the sine of that other answer. Okay. And then lastly, B is actually going to be the same for both of them because it's the input, it's the given. So the X is going to be this, and the Y is going to be C, right? It's in this case, it's negative for the problem that they assigned, and so it's going to be the same for here. So we don't actually need to have found theta 3 to be able to do this plot, but it will help us. Okay, so I'm going to cheat by grabbing 3 of those columns and plotting them, and then so one of these configurations, the blue one right here, is actually correct. It's this orange one is the one where I've been cheating. I'm just going to grab a hold of it and slide these over. And so these are the 2 different possible configurations that we have. If you want to do the same thing we did in the previous example, where we let's see, I get rid of that border line, and let's say I like to put the legend inside there so I can use up the space right in here. If the thing was actually going to be proportional, we want to have these divisions by look like squares. So let's see, the vertical one is by 10s. Hey, that's actually not too bad. They look pretty close. They look pretty square there. So these are actually the proportions of this. And so we can take a look at our answers up above. Our first answer for theta 3 for the first configuration, that looks like this right here, is 150 degrees. So taking from this point, and this is the location of the piston based on these the inputs that we have, we take theta 3, go counterclockwise from horizontal, and that does look like 150. We come to 100, this one right here, and coming around, is that 172? It's not, but it is 172 going clockwise. It's one of the issues that we're getting when we have our values in that are being arrived, right? It'll take the shortest route to get that. So generally speaking, Excel won't give you something that's I got to be careful to say this because you can get something that's greater than 180 degrees, but quite often instead of giving you 180 degrees, it'll flip the other one. So its sign conventions won't be perfect. So that's example 2. I'm not going to go into the longer thing where we might have to go and try some of the other angles. So we'll go on to the next video. Thank you.